Hello everyone, and welcome to the implementation of Quicksort lecture. So, as a reminder, the Quicksort algorithm first selects a value, which is called the pivot value. Although there are many different ways to choose the pivot value, what we do is simply use the first item in the list. The role of the pivot value is to assist with the splitting of that list. The actual position where the pivot value belongs in the final sorted list, commonly called that split point, is then used to divide the list for subsequent calls of the quicksort. So again, you have resources for review, and you can check out the previous lecture if you want more coverage on the theory of quicksort. But we're going to go ahead and implement our own quicksort algorithm. So this is probably going to be one of the most involved out of all the coding of the algorithm, so just keep that in mind. We're going to have 3 separate functions in order to make this happen. So let's go ahead and just dive right into the code before we break it down line by line and explain what's actually going on. All right, so first thing we're going to do is just go ahead and start our function. So we're going to say def and say quick underscore sort. And then let's go ahead and pass in an array. And what I'm going to say right now is just pass, and I want to make the skeleton of all the functions we're going to use. Next one we're going to use is called quicksort helper. So this original quicksort function is going to just do, it's going to invoke a recursive function called quicksort helper, which let's go ahead and do it. We'll just say quick underscore sorts help, and that will take in an array and then a first and last marker. And we'll say pass right now. And then finally, the last one we're going to say is partition. This will also take the array, first and last, whoops, and then we'll say pass. All right, so we have the quicksort function, and then it's going to invoke a recursive function, quicksort help, which begins with the same base case as that merge sort. So if the length of the list is less than or equal to 1, it's already sorted. If it's greater than, we can be partitioning and recursively sorting that array. So that's what the partition function is going to do, and it's going to implement that process we described in the previous lecture. So let's go ahead and get started. So we have quicksort, and all it's going to do is, like I mentioned, just going to call quick sorts help, and it's going to take in that array. We'll start off at 0, and then go to length of the array minus 1. And the reason for that being is the way we set up our n values when we do partition. So quicksort help, we're just going to say if first is less than last, we're going to set up a variable called split point. And then that's going to be returned from the partition call. And again, partition is just going to take in the array, first and last. And then similar to the merge sort, here we're going to call quicksort help twice. On the array, first, and then all the way to the split point, minus 1. And then we're going to call it again quick underscore sort underscore help on the array, and then from the split point, plus 1 all the way to the last element. So this should look really familiar from the merge sort implementation, where we had that recursive call, one on that first left half, then the other one on that right half. So now let's take advantage of this and fill out our partition function to really start doing the merging and that quick sorting. So let's go ahead and create our pivot value. We'll say pivot value as a variable and just have it be that first element. As I mentioned, there's different ways of choosing the pivot value. For this simple implementation, we're just going to use that first element. So then let's go ahead and make those marks. So hopefully you remember from those figures, we had that left mark and that right mark. And just like we did in the last lecture, theoretically at least, I'll set left mark equal to that first plus 1, and then right mark just equal to last. And then what I'm going to do is set up a while loop. And in order to make this a little more readable, I'll set a variable called done, and have it be equal to false. That way my while loop can read something like this, while not done. So that will allow us to have a really nice readable while loop. And then I'll say while that left mark is less than or equal to the right mark, and the array value at the left mark is less than or equal to the pivot value, then I'll just say left mark is equal to left mark plus 1, which I can just write like this. And then I'll say another while loop, while the value at the right mark in our original array is greater than or equal to the pivot value, and the right mark is greater than or equal to the left mark, then the right mark is going to be subtracted, have 1 subtracted from the right mark. So remember from that last lecture how we move them closer to each other. So left mark starts moving to the right, and then that right mark starts moving to the left, as long as these two conditions end up being true. And then finally, if we say if right mark is less than the left mark, so remember that was that crossing point, then they're done. So we'll say done equals true. Otherwise, they're not done yet, so I'll say else, and this is where we basically do that switching. We'll say create a temporary variable of the left mark value, and then set left mark equal to the right mark, and then set the right mark equal to the temp. So that's basically just the way we're switching those values once they cross over. All right, and then what we're going to do is outside of these while loops, or essentially outside of this while not done, we have to do one last switch here. We'll say temp is equal to the value at first, and then that value at first is then going to be equal to the right mark, or the value at the right mark. And then the right mark value is just equal to, temp here. And then we can just return the right mark, since we'll be calling partition here, which is basically just returning that split point. So partition is just going to be returning that split point after doing these operations. All right, I know that was a lot of code, so let's go ahead and check it out, make sure it all worked, and then we'll break it down further. So I'm going to say an array. Let's go ahead and just copy and paste this from that Jupyter notebook we already have. Make sure this all worked out. Okay, looks like it's sorted and looks like we're good to go. So let's go ahead and break down what's going on here in our implementation of Quicksort. So remember the first thing we had to do in Quicksort was select the value, which is called that pivot value, which is what we have here while we're making the partition. We're selecting that pivot value, and in this case, we're selecting the first item in this list. And the role of the pivot value is to assist with splitting the list. So the actual position where that pivot value belongs in the sorted list, commonly called that split point, which is what we end up returning from a partition function, that's going to be used to divide the list for subsequent calls of Quicksort, which is what we're doing here. Okay, so we have our first pivot value, which is going to be that first element. So then this partition process is what's going to happen next. We have our left markers and our right markers, and what this partition process is going to do, it's going to find that split point and at the same time move other items to be on the appropriate side of the list, either less than or greater than that pivot value, which is what we're doing with these checks here and here. So as I mentioned, that partitioning begins by locating those two position markers, that left mark and the right mark, at the beginning and end of the remaining items in the list. And the goal of this partition process is to move items that are on the wrong side with respect to that pivot value, while also converging to that split point, which is why we slowly start to move the left mark to the right and that right mark to the left. And then specifically, we begin this process by just incrementing left mark here, the incrementation, until we locate a value that is greater than the pivot value, which is what we're doing here. Okay, so then we decrease the right mark until we find a value that is less than the pivot value, which is what we're doing here. So basically once it breaks, what we're doing here, once it breaks and is greater than the pivot value. So at this point, then we've discovered two items that are out of place with respect to that eventual split point. And then we just exchange those two items, which is what we're doing here, and repeat the process again. So at the point where the right mark becomes less than the left mark, that's when we stop, which is our done statement here. And then we know that the position of the right mark is now the split point, and that pivot value can be exchanged with the contents of that split point, and the pivot value is now in place. And in addition to all this, all the items to the left of the split point are now less than the pivot value, and all the items to the right of the split point are greater than the pivot value. So the list can now be divided at the split point, and the quicksort can be invoked recursively on the two halves. In this case, we used quicksort help on those two halves here. Okay, so that's the basics of matching up what we theoretically talked about in the previous lecture to an actual implementation of the algorithm. I would really suggest that you use print statements wherever you feel uncomfortable or confused about our implementation here to print out what's actually going on. And when you're doing that, go ahead and switch this array to the same numbers that we used in the previous lecture so you can actually see your array be printed out in the same way that we have the figure in the previous lecture on those slides. And that's going to be a really useful way for you to build out your understanding of the algorithm, print out, follow along, and really understand how the partition and quicksort process is actually working. And if you still need more help, again, if you go to the Jupyter Notebook, there's resources for review, such as the Wikipedia page, visual algorithm, etc. All right, so that's the implementation of quicksort. Thank you, everyone, and I will see you at the next lecture.